Hi there. Hope you have a fantastic day today. This lesson, I will teach you how to solve problems involving exponential functions. Of course, there is a PDF version on the description below for you to download so you can work with me. Otherwise, let's go straight into it. In 2010, the city of Pythagoras modeled the predict population of the city using the equation P is equal to I times 1.04 power of n. That year, the city introduced a policy to slow its population growth. The new predicted population was modeled using the equations P is equal to I b power of n. In both equations, P is predicted population, n is the number of years after 2010. The graph shows the two predicted populations. So let me just write this down. So first of all, we know this prediction here is without policy introduced. So let me just write this down. Where this one here, P is equal I b power of n, okay, when the policy is introduced. So both are predictions, okay? Just remember that. First one, use the graph to find the predict populations of Pythagoras in 2030 if the population policy has not been introduced. So in 2030, that is without policy. So 2030 is here. That is n is equal to 20. So it should be here. So that is there you go. So therefore, we need to work out. So each gap is going up by how many? Okay. So we have 1, 2, 3, 4, 5. So each of these is 1 million. So therefore, we just go 1 million divided by 5 because we cut into 5 gaps. So let me just use calculator. So if I go 1 million divided by 5, and it should go up by 200,000 people each gap. So let me just write this down first. So each of these is 200. So this should be and 200,000. So we have 1, 2, 3. So 62, 64, 66. So let me just write this down. So 6,600,000 people. So there you go. Part 2. Each of these two equations given, the value of I is 3 million. What does I represent? So 3 million is here. So therefore, it's starting at n is equal to 0 and it's starting at 2010. So that means, so therefore, I is represent the initial populations, which is starting from 2010. Part 3. The guess and check method is to be used to find the value of b in P is equal to I b power of n. Explain with or without calculations why 1.5 is not suitable first estimation for b. So first of all, we need to look at the model. So you can see the model for the first one without policy. P is equal to I times 1.05 power of n. And then the predictions we use with the policy is P is equal to the first estimations. Let me just write this down. So we estimate like this. I times 1.05 power of n. Now by looking at this model here, we know that if it is 1.05 power of n, so the graph, it should be somewhere above this line here, okay? So that is for I times 1.05 because 1.05 is greater than 1.04. So therefore, it should be above that graph, not below. Okay, so therefore, the first predictions 1.05 is wrong. So let me just write this down. So I times 1.05 power n. So therefore, the graph should be above P is equal to I times 1.04 power n. But it's actually below. So therefore, so there you go. Okay, so keep that in mind. 1.05 is greater than 1.04. So if B equal 1.05, so it should be above this graph, not below. So therefore, the estimations is not suitable for B for 1.05. Part 2. With n equal to and P is equal to 4,460,000, use guess and check method and estimate the P is equal to A B power n. To estimate the value of B to 2 decimal place, show at least 2 estimate values for B, including calculations and conclusions. So obviously, we just have to use guess and check method. Okay, that's what the requirement from the questions. So let me just write down the equation first. So we know that P is equal to A, but we know that A from the graph is 3 million. Okay, so this is here. That's the value of A, and also given here as well. Okay, just keep that in mind. So let me just write this down. So P is equal to A, that is 3 million. And then B, so we just write B first because we don't know what it is, and power n. Now to guess for the value of B, so first attempt, so we need to look at the graph first, okay? So the graph here, because with our policy, so A is equal to 1.04 power n. But then, because this graph here is have to be below that, so therefore the value of B should be less than 1.04. And then we're gonna guess correct to 2 decimal place. So it should be the one down is 1.03. So we try that first. If it doesn't work, we try 1.02. And again, we can try 1.01. Okay, that's how we find the value of B, by just guessing check. So we start with 1.03. So B is equal 1.03. So it should give us 4,460,000. If not, and then we have to try a different value. Okay. So that's 3 million. And then we times by 1.03 power n. So n is 20. Okay, so we try to get to this value here. So now what I do, I just put that on a calculator. So I just go 3 million times 1.03 power 20. So there you go. It's above 5 million. So therefore, we should change the value of B to 1.02. Okay, if it's still too much, then we try 1.01. So let me just write this down. So that is 541,833.4. So now we need to try one level down. So that is 1.02. So let me just move this up. B is equal to 1.02. So this will give me P is equal to 3 million times 1.02 power 20. So that should give me, so I should change that to 1.02. So there you go. Very close now. So let me just write this down. 4, 4, 5, 7, 8, 4, 2. Let's try when B equal 1.01. See what happened. Okay, see if it get closer than that. Okay, so when B is equal to 1.01, so that will give me P is equal to 3 million times 1.01 power of 20. So that will give me, so I change that to 1.01. There you go, a lot less than 4 million. So therefore the suitable value for B, it should be 1.02. But let me just copy this down first. So 366,0570. So we can say therefore B is equal to 1.02. So that is the value of B. Part 4. The city of Pythagoras was aiming to have a population under 7 million in 2050. So important is 7 million, that is under and in 2050. Okay, keep that in mind. Does the model indicate that the city will achieve this aim? Justify your answer with suitable calculations. So first of all, let me just write down the model first. So we already know that B is equal to 1.02. So let me write down the equation first. So the populations for the policy introduced is A, which is 3 million, times by B. So that is B is 1.02. We already found what the value of B and power of n. So we need to work out in 2050. This means that n is equal to 40. Because from this graph here, so we know that the graph starting at 2010. So in 2050, that means 40 years later. Okay, so keep that in mind. So when n equals 40, let me just write this down. When n is equal to 40, so P must equal to 3 million times 1.02 power 40. Now, if I put that in a calculator, if the value of P less than 7 million, so this means that the model is indicate the city achieve the aim. If greater than 7 million, so therefore it will not achieve the aim, okay, just to let you know. So let's work it out, okay. So what I do, I just change the value of B to 1.02. And the value of n is 40. So there you go. 6,624,119 people. Okay. There you go. 6,624,119 people. So that is below 7 million. So let me just write this down first. So therefore, so there you go. Thank you so much for watching. Bye.